scientists have come closer to confirming one of Stephen Hawking's biggest theories on black holes. Before Stephen Hawking passed away in 2018, the physicist put forward a theory that contradicted the notion that it was impossible for any object to escape a black hole. One of his most famous assertions was that black holes can actually emit a form of radiation. Researchers now believe they've found the equivalent of Hawking radiation in laboratory experiments that mimic black holes in light, sound, or water. It's hard to talk about black holes without mentioning Stephen Hawking. Before he passed away in 2018, the world-renowned physicist had devoted his entire life to exploring various theories on cosmic phenomena and creating his own theories. One of his most famous assertions was that our understanding of a black hole's event horizon suggests that, actually, no black hole is an entirely black hole, with him saying, "Black holes ain't as black as they are painted." Quote, "In the context of black holes, the event horizon is a hypothetical interface in spacetime separating a black hole from the rest of the universe, and events beyond this point cannot affect an outside observer. It's the boundary at which gravitational acceleration becomes so great that it would make it impossible for any object to escape. Even if a ray of light were to cross, it would never leave again. Every object in the universe carries information about its structure and shape that can't just dissolve, but this is theoretically what would happen if an object were to go into a black hole. In general relativity, you simply can't escape a black hole. Once you're in, there's no going back." However, in 1974, Hawking put forward the theory that a black hole does in fact emit something when you throw quantum mechanics into the equation. He hypothesized that black holes had an apparent horizon, across which matter and light could move, while leaving behind particles, now also known as Hawking radiation, that could leave the black hole. The researchers reconstructed imitation black holes. Just days before he passed away, Hawking had been working on the topic, trying to confirm a theory. He concluded that the event horizon was surrounded by a ring of photons that could reflect the information from the black hole. So far, however, this is just a hypothesis. Until recently, there had been no evidence to confirm Hawking's suspicions. However, researchers now believe they've found the equivalent of Hawking radiation in laboratory experiments. A study by researchers from the Weizmann Institute in Israel has demonstrated that we've come a step closer to generating Hawking radiation in an optical black hole, the results of which were published in Physical Review Letters. Hawking radiation can only occur in conjunction with an event horizon. The premise behind Hawking radiation is that the very fabric of space is riddled with quantum fluctuations. These fluctuations create pairs of particles and antiparticles, which are short-lived because they almost immediately annihilate each other. But at the edge of the black hole, quantum pairs can be separated. While one particle in the pair falls into the black hole, the other can escape, resulting in radiation. In lab-generated black holes, also known as dumb holes, researchers can create a kind of event horizon in a medium that can produce waves, such as light, water, or sound, in an area where waves aren't able to escape. These experiments essentially mimic black holes. Although these simulations don't produce the gravitational effects that a black hole would, the same mathematics in these experiments can be applied to the mathematics used to describe black holes under general relativity. Hawking radiation is a much more general phenomenon than originally thought. It can happen whenever event horizons are made, be it in astrophysics or for light in optical materials, water waves or ultracold atoms, said lead author of the study, Ulf Leonhardt to Physics World. The team chose to use an optical fiber system Leonhardt had developed previously and found that negative light was drawing energy from the event horizon, indicating stimulated Hawking radiation. While previous dumb holes have simulated Hawking radiation, this experiment claims to see actual Hawking radiation in the form of particles of light called photons. Though these results are exciting, the aim is to observe spontaneous Hawking radiation, the sort that would come from a black hole, as opposed to stimulated radiation, though it's impossible to exactly recreate in the lab the conditions around an event horizon. "We plan to investigate this next," said Leonhardt, "but we are open to surprises and will remain our own worst critics."